So let's start off our section number 4 of presenting research findings, in which we're going to talk about presenting statistics. So we now know about the abstract and of the sections of the main body of the manuscript, but how to present statistics? We have a lot of numeric values, we have p-values, tables and graphs, but how to present them in our manuscript in an efficient manner? So that's what we are going to focus on in this section. So let's start off with the numerical results. So whenever we analyze our data on a software, there is a lot of values and software gives results to many decimal places. So those are very long numbers and figures. So those should be rounded for presentation in your manuscript so that it is clear to understand and your manuscript looks clutter-free. So present means, averages, standard deviations, medians, modes, standard errors to one or more decimal place, one decimal place or two decimal place, but that should be universal throughout the manuscript. It should not be like that one number has 2 decimal places and one number has 4 decimal places, or one number has 1 decimal place. No, it should not be like that. It should be same throughout the manuscript. So we said that we should round off. The second thing is how to deal with proportions in numeric data. So when we are dealing with proportions, so you should also round them off to 2 significant figures or something that you feel comfortable with. State the actual number as well unless it is obvious with the proportion. So state the actual number. If it is not obvious, then do mention it. Present a proportion as a percentage if it is very it is small, like for example 1 out of 100 or 2 out of 100, so it will come as 0.00 something. So just give it as like 2 out of 100 means 2%, 1%, so just mention it like that instead of giving decimal places. So very small proportions may be easier to read if given as rates per 1,000, per 10,000, etc. But if it is even smaller than that, for example 0.1 out of 100 or something like that, 0.001 out of 100, so then you can give it as, for example, 1 per 1,000. So you can give you can present your numeric data in that way as well. So present your numeric data in a way which is clutter-free, which is easy to understand, and which is easy on the eyes, because that is very important. So percentages. So we talked about rounding, we talked about proportions, now percentages. So present percentages once again to 2 significant figures, but give the actual numbers as well if they are not obvious. For example, I say 10 people out of 100. So the percentage would be 10% and n would be 10 as well. So you don't need to mention the n. But if it's something like 20 out of 200 or something which is not obvious, then you should mention the total number of the subjects as well. And beware of presenting percentages for very small samples as they may be misleading, and simply give the numbers alone, because if there is total subjects are 10 and there are 3 out of 10, so percentage for that can be misleading. So don't do that, just mention 3 out of 10 individuals. Now here is an example, a practical example, how you should present mean and standard deviation descriptively in your manuscript. So mean and standard deviation for blood pressure in 1,753 pregnant women as given by statistical program as systolic mean is 112.0553 and SD is 11.17655. Now this is very cluttered, it's not easy on the eyes. So if you can round it off, it becomes very easier. So systolic mean and standard deviation, so to 1 decimal place, so 112.1, very easy to understand, easy on the eyes. And similarly 111.2. Now it is giving the same information, but it's clutter-free, it's easy on the eyes, it's easy to understand. Now how to present proportion and percentage. So proportion of smokers in a sample is 484 by 1503, which gives 0.322. So Instead of mentioning 0.322, why not mention it as a percentage? So multiply it with 100 and the percentage of smokers becomes 32%. Now, it is easy to understand, it is clutter-free, it's easy on the eyes. Proportion of stillbirths in England and Wales. So 3532 divided by 643, so 0.005. So now it is very small. Even if we convert it into a percentage, it would be still in decimal places. So why not present it as rate per 100 total births? So it would become 5.49 per 1000 total births. So it becomes very easy to understand and once again clutter-free and easy on the eyes. Now, presenting p-values. P-values is something which is very important statistical figure because it is the thing that tells you if something is significant or non-significant. There are numerous ways to present it in your study, to interpret it, and to mention it. So the first way is the statistical program gives p-values to many decimal places. So p-value can be reduced to a yes, no, or significant, not significant figure. So if it's less than 0.05, just say significant, and if greater than 0.05, just say not significant. So it is adequate if the estimate and a 95 confidence interval is also mentioned. But the problem is that it does not provide sufficient information. Let's take an example which is mentioned here. So we have two p-values. One is 0.04 and one is 0.06. One is slightly above 0.05 and one is slightly below 0.05, and there's not much difference, to be honest. But the representation of the findings would be significant, not significant. So you're calling 0.06 as not significant and 0.04 as significant. So reading the descriptive interpretation, the reader would understand, oh, there is a lot of difference, but in fact there is not. So it can be misleading because it does not provide sufficient information. Another way to do it is giving the actual p-value if the test is statistically significant, which means if p-value is less than 0.05, then mention the actual p-value, otherwise just mention that it was not significant. So as mentioned here. So it is not helpful as the size of the p-value indicates the amount of evidence for a real difference or real effect. So presenting it as it gives the reader the opportunity to see all of this evidence where it is significant or not. So it is better than the previous way, but still it cannot give an opportunity to the reader to see all of the evidence. Now, another way to interpret it is p-values are probabilities and they are presented as proportions. So unnecessary to report to many decimal places as this obscures the meaning. So another way to present it would be to present it as p less than 0.05, p less than 0.01, or p less than 0.001. So instead of just saying less or greater than 0.05, we are also using 0.01 and 0.001. It is the benefit of it would be that it takes a very small amount of space, and it is very good when you are using it in tables. And stars are not needed if the actual p-values are given, but if you are not giving the p-values, then you can mention the stars and mention at the end that 1 star means this, 2 stars mean this, and 3 stars mean this. And it is very helpful if there's a limited space, especially when you're working with tables and graphs. So in general, the following is recommended for p-values. Give the actual p-value wherever possible, and if not, then you can go for either of the 3 ways which is most suitable to your manuscript. And rounding, 2 significant figures is usually enough, but you can go on to 3 significant or 2 decimal places, however you feel better. But it should be important, it is important that you should keep that theme throughout the manuscript. So here's a practical example. So the following are p-values as given by a statistics program. They can be rounded and reported as shown here. So the rounding off here is to 2 significant figures or 2 decimal places. So 0.811 is 0.81. But sometimes you get that 0.000 is the p-value, or 1.00 is the p-value. So you should not interpret as 0.000, because p-value can never truly be 0 or can never truly be 1. So report it as less than 0.0001 or 0 greater than 0.999. So that is another important fact that you should consider whenever you're mentioning or presenting statistical values in terms of p-values. Now, presenting statistics in terms of tables and graphs, and it is very important and a very easy way and a very good way to present your results in the results section. So, useful way of presenting the results of statistical analysis. In written reports, a table or graph should stand alone. It should be sufficient enough. So when you take a look at it, it should give all the information, and you do not have to read the text to understand what this graph or what this pie chart or what this table is actually trying to convey. It should be sufficient and it should be stand alone. Now, what are the general guidelines for tables and graphs? There should be a meaningful title that explains what the data is included. So it should stand alone. Number of subjects or data points should be mentioned, the total number. Label rows and columns, like for example, rows, for example, what is the variable which is present in the row, what is the variable which is present in the column, you should mention that. And also mention the variable on, if you're talking about graphs, then mention which variable is on x-axis, which variable is on y-axis, etc. State any units used. For example, if you are here, we are using blood pressure, then if you're using millimeter per mercury. If you are using force, then Newton. If you're using distance, then meters or centimeters or whatsoever. Refer to the table or graph in the text of written report. So wherever you are putting a graph, you should mention that in the text as well, which corresponds to the relative descriptive statement of that graph or table. Avoid graph with missing zeros or stretch scales, which can exaggerate relationships, which we're going to look at an example in the upcoming slides. So presenting statistics in tables, here we can see that this table has a clear title. The table should have a clear title, and the numbers and percentages are given, and relative risks are given with 95% confidence intervals. So you can see here is the total number along with percentages. And here we have variables mentioned in columns as well as variables mentioned in rows. And there's also a footnote. You can also put in a footnote which explains which way around the relative risk was calculated. Or you can, sometimes we use asterisks and footnotes for p-values if we do not mention p-values in the tables. So you can use footnotes for any purpose. Now here is an example of a graph, and here you can see that there are two graphs which look very different from each other. But in fact, they are presenting the same statistics and the same findings. The difference is because this actually phenomena is known as stretching, to make a graph visually in such a way that the relationship seems more dramatic. The author or the researcher has done it by giving values like here were 3, 4, 5, 6, and here he is going 3, 4, 4.2, 4.4, like stretching this scale, keeping this scale at the same level but stretching this scale. So the 6 would be around somewhere around here, for example. So this has actually made this effect look more dramatic, and the researcher is trying to influence the perception of the reader, which is not a right thing to do. So avoid doing this. So that was all about the section number 4, and I hope you learned something new out of it. Keep on watching sqadia.com for more lectures like this. Thank you very much.